Today is to measure this helical gear, which I bought from Amazon.com. And I have the program for measuring gears, both helical. So I plugged it in and I used Explorer. So here's where it's located, Drive F. And this is the application for GearCat. GearCat is just a small app. It doesn't need anything else installed on your computer first. You just run it, and if it finds it needs to install files, it'll do it. So that makes it easy. So I'm going to click on it, and it brings up this screen. This is the app. It has a zCAT number, it has your IP address, connections, and then it has some information it needs for the specs on the gear and the shape of the gear. So we're going to fill that in so you can get going. Let's see, the first step, we should put in the zCAT number, which is mine, 1510001. 0001. It's an old one. It's one of the first ones. And then I'm going to need to put in the IP address. That's 192.168.2.17. Now, if everything is ready over there, I should be able to connect. Oop, I better make sure that I have, nope, I had not selected to connect to zCAT, so we'll do that. Okay, so we now have a connection. We have a DRO that's working, so that's good. And I am going to be working with this very small probe combination. I've got a 2 millimeter on the vertical and a 1 millimeter on the horizontal. So let me select that group, which is my group 3 here. It's a VP3. Okay. Now I need to fill in the information on the gear. First thing I need to do is switch to inches, because I went over to my Amazon and I see that values are in inches. You can see the 5/8 bore. So select for inches, and oh, we need to name this too. So this gear number is H1224L, so let's put that in there. H1224L. That's good. Now, number of teeth. We have 24 teeth, so we'll put that in. And the pitch says 12, okay, 12. And then it popped up with 2 inches here. That's the pitch diameter. It calculates that from the 12 and the 24. Pressure angle is 14.5. So let's just click pressure angle. There are only 2 that are commonly used, 20 and 14.5. And then we have a helix angle, which is 45 degrees. So we need to put that in there.
If it didn't have a helix, it would just say it's 0?
0,
okay.
Right, like for spur gear.
Right, okay.
The style you don't have to worry about now. I'm going to use that later for maybe special kinds of configurations of a gear, that the way the shaft is aligned or something that's special. But right now it's just style 1. Hub extension, if you look at the gear for the helical, the hub extension would be 0, because on the spur you can see it's up maybe 5/8 of an inch, but ours is 0, so we don't have any hub extension. We do have a bore, and let's go back to Amazon. It's 5/8, so that's 0.625. So we got that. Okay, level 1, level 2. This has to do with how many circumferential paths you want to run around the part. So you can put one in and then it'll just measure one path. If you put both levels in, you get two paths. So I'm going to go down, in this case, probably 1/8 of an inch. And then I'll do another one, maybe down a half. Let's see, should I go down about a 1/2 inch? Yeah, let's go down
Okay.
a 1/2 inch. Okay, and let's see, what else do I need? I think that is it. So it says select probe and input gear values. So I did that, and then click go. All right. I'm going to make one more check to make sure that everything is okay here. So let's go. And it says probe over gap between teeth. So I got to put the probe at a starting point. And I also like to, if there is a keyway, I like to have it pointed toward the machine so that it misses that when I do my measurements for the bore. So let's get the probe between the teeth. This is going to be using the vertical. You see there's a gap that's down between the teeth? See where I'm at? I'm roughly right there in the pitch diameter area. And I've got that is kind of lined up with on the side of the machine. So what it's looking for is, okay, there's the gap, probe is over it, and away from that is going to be where the bore is located. So I should be able to hit go and see this thing, see it start to work. It's going to go down and get the height of the gear, and it's going to go over and measure that bore.
It'll miss that.
Yeah, I put in
because of
5
that.
hits, so it'll miss that
It'd be an
keyway.
odd number, okay.
Right, it misses it. Now it's just going to get the plane of the gear. And then it switches to the horizontal probe, because now it's got to get down in there and start measuring. First thing it has to do is just locate where that gap really is. So it takes a number of hits to get an idea where the tooth form actually is starting, the gap form is starting. This is kind of a slow part of it, but necessary.
So it's almost like it's going of the form almost.
Yes, and now it's going to test that. And it failed. So we have an operator failure. Done. Failed. Connect. So I said it was operator fault, which is normally the cause of my problems.
In mine.
If I had looked over at the Amazon information, it said 45 degree, but it is a helix, but it's a left hand where it's over there. See it? See LH?
Yep.
Okay. Left
Probably
hand.
the L on the part number 2 means left hand.
I guess so, yeah. So you have to put a negative in here because it could go either way. If you have two miter gears working with each other, one's left hand, one's right hand.
Exactly.
And if you have both left hand, then they end up at 90 degrees to each other. So I have to get the negative in there. So we've got this running. Oh, I don't have a DRO, so I've got why don't I have a DRO?
Maybe we need to reboot the zCAT. Okay. Are we good?
Yeah, a little bit out. There. Okay.
Okay.
Now I'm going to click go. So it says probe over gap between teeth and select go. Nah. Yeah, I've got 3. Okay.
This is the height again.
Correct. Now it's going to test that alignment.
Take 1 point on each side then.
Right. So now it's ready to go and measure each gap. So it's the tooth on the
So
one
that's
side
at that
versus
first height you set, correct?
yes, and it shows which number it's measuring.
So it's going to number the teeth, and there's
Should be
24.
Correct.
And it's doing that 1/8 inch height right now?
Yes.
125?
Down.
How small do you think realistically we could go on this?
It really depends on the diameter of the probe ball. And if we use almost down to a wire size, like 10/1000ths of an inch, you should be able to get up to 64 pitch.
Because the smallest ball that I've seen available for us is 0.3 millimeter.
Okay, that's 12.
That's going to be about 12 thousandths?
Yeah, 12/1000ths, right. Mm-hmm.
So I can see it's even vectoring to the surface based on the angle that we
Yes,
have too.
yes. So all the programming is automatic. You just have to put in the parameters
You have to put in the parameters correctly.
correctly. Right.
and position the probe correctly.
Yes, yes.
So it's not a huge thing as long as you know that information.
Correct.
Now it's going to go down and do the 1/2 inch one.
So we're at the lower level. And if you didn't put anything in that level 2
It would be
area,
finished.
it would be finished, right. Which you typically do for a spur gear.
Right. Now what if, I know that's 2 gears right there, but imagine having a gear like that had one at the bottom, one in the top, or even one at the bottom, one in the middle, and one at the top, which I've had applications like that. Could you see modifying this to do all 3 of those? And is that a challenge that you'd want to undertake?
That would be tricky. I would still want to do each one separately.
Okay.
But they all can work off the same bore and plane information. So they still would be referenced together.
Okay. So once we've done the 24 twice, or 48 total,
Yes.
then we will have the results.
Yes, and it'll be displayed, but also will be on a file on the computer.
Okay. Under that file, under the name of this particular
Yes.
gear that we've
Yes.
given it.
Yes. On the screen, you can also see it shows run number. So if we repeat that, it automatically go to 2, and then 3.
Okay.
So the data is stored by the run number and the part number.
Do you think it's feasible to fixture a gauge so the operator would just have to put it in place and go, or are you still going to have to manually align it?
It would, once you do it as I did it, if you put the gear back in that position,
It's going to remember that.
it's going to remember that.
Okay.
And the style also, I've allowed to be another kind of a number that would represent a fixture that needs to be measured. So I haven't done that yet.
Okay.
We're finished. So this is the first bit of data to look at. The average size of the tooth is 1/1000th undersize. And that's typical because you need to have a little bit of clearance between gears to have a little bit of backlash, otherwise they would bind. So it's typical to see that the gears are cut slightly undersized on the tooth shape. The max error on this thickness of the tooth is 1.9 thousandths of an inch.
And what's that telling us? That's the maximum error of any one of those measurements it took?
Yes.
Of those 48 measurements?
Yes, so
Okay.
looking all the way around. And then the last value is the CTE, which is the composite tooth error. And this is looking at each surface that we measured. So we had 24 teeth, so we had on both sides, so that's a total of 48 points, surfaces. What is the maximum error of a surface relative to the bore and the top plane? What's the maximum error? And that was 1.5 thousandths.
So that's the CTE?
Yes, that's the composite tooth error. So
Okay.
you can go to any one of those surfaces, how much is it off?
Okay.
Using the bore as a reference, not the other teeth, but using the bore.
Okay.
So,
And that's the typical information that they're going to want when they're checking gears, correct?
correct. And then we look on our files. Let's go to my C drive, and I'm going to go down and to program data here, and then go all the way down near the bottom, and you'll see zCAT. Now, this is created when we start up with our thumb drive. This file is created automatically if you don't already have it. So we can then look at the gear results. And we have two files. We have text file, which gives the information that we see on the screen, like bore with
Okay.
the
All the
error,
information
yes.
that we input plus the results.
Yes. And then if we close that one and look at this one, this is for Excel. And since my Microsoft Office quit last night, I don't think the Excel is going to work.
But it would bring up a spreadsheet
Yes,
with all the results, and we could create a template so that the results would be
exact.
in there.
Oh, we did bring it up. There it is.
Okay.
So, and this is going to
That's
need,
just that one gear, though.
yes. See, this is number one. This is
Right.
our run number one. And if you had a bunch of runs, they'd all be down through here.
Okay.
And this needs a formatting.
You create a template. So
Right.
if we ran 10 gears, we would have 10 lines.
Yes, yes.
And the results for each one individually.
Correct. So let's quit that and see what else is on here. We have gear files. Okay, this is, every time we have a different part number, you'll see it here. And let's look at it. These are all text files. And it shows what version of GearCat we're running. It also gives me the machine number, gives the date, and 5. Forgot what 5 is for. We're in inches. We got 24 teeth, 12 pitch, 2 inch is the pitch diameter, 14.5 pressure angle, minus 45 degree helix angle, and no extension, 5/8 bore. We're going to measure 1/8 of an inch down and 1/2 inch
Okay.
down. So that's just all that's information for the setup. And then there's one other file that it is created. Well, this is connection. That just gives us the connection that we used for this gear, which is shows the machine number and the IP address. And the guess.
Okay.
So these are all created automatically for you, so you don't have to do all that. Let's go to program data, or program files. And zCAT there's a zCAT. And this is used then to store anything that's specific to the I++ connection. In this case, I didn't need anything special, so it didn't put anything in there. So those are the files that have been created, so that you know when you look in there, where did that come from? It came from running the GearCat. If I quit this, let's just disconnect and quit. And then let's run again. Let's go to my thumb drive and click on GearCat. It brings everything back the way
From the last
Last
one.
run,
If it was
right.
everything was the same, you could just hit,
right.
and nothing is moving, you could hit,
And let's
Go.
let's connect.
yeah, obviously, connect. Make sure your
Connection
DRO
success.
is on.
Okay, and then we should be good to go. It says probe over gap. I left it there, so it's still there. And then go. And now we're on run number 2. So once you set up a gear, then you can do it without having to put in all the parameters. And when you change the gear number, you can hit load and load in
Okay,
another number.
okay, very good.